Hello, thank you for watching this video. So in this video, I'll be doing question 4 of November 2021 question paper mathematics paper 1. And it seems like these are patterns. So let's do question 4. Question 4 reads as follows. Consider the linear pattern 5, 7, and 9. So you are told that to consider this linear pattern here, which have the terms 5, 7, and 9. So linear pattern, right, are arithmetic sequences, arithmetic patterns. That's the most common name that many people are familiar with. Even if you don't know it, you can investigate what kind of a pattern is this. You should not be demotivated by the name. Linear pattern, what is that? And then you're just like, okay, I've never heard about this, I'm stopping here. So if you don't know what a linear pattern is, you can investigate. You know how to investigate patterns. You know which patterns you normally do at grade 12. It's a linear pattern or arithmetic pattern, geometric pattern, and quadratic patterns. Those are the patterns that you have. So this should be one of them, at least. So consider the pattern, the linear pattern, which have these 3 terms here. And then this pattern of yours continues. Fine. Determine term number 51. So they want you to find term number 51. So what do you have? You say, okay, I have my linear pattern. It has 5, 7, 9, and then it continues, right? The difference between all terms is 2, right? So what do you want? You want term number 51. So your Tn, your general nth term, is called A plus n minus 1 times D, right? So Tn is equal to A is your first term, it's 5 plus n minus 1 times D, your D is equal to 2. So if you want term number 51, T51, so T51 is equal to 5 plus 51 minus 1 times 2. You want T51, right? So you just punch this on your calculator. Further, this minus this is what? It's 50 times 2 is 100 plus 5. So you will discover that T51 is equal to 105. Your term number 51 is equal to 105. So you're done with this question. This is 4.1. Then we move to 4.2. Calculate the sum of the first 51 terms. They want you to find the sum of the first 51 terms. So how do you do this? You say, okay, sum Sn is equal to what? N over 2 into 2a into 1 minus, into n minus 1 times d, right? This is how you do this. Or say Sn is equal to n over 2 into a plus l, where l is your last term of the sequence. So you know what your 51st term is. The 51st term is 105. So your last term is 105. So you can substitute here. Your n is 51, your a is 5, your n is 51, your d is 2. Then you find your answer. Or you can just say sum of 51 terms is equal to n, which is 51, over 2 times a. Your a is what? Your a is 5 plus your last term. Your last term was 105. Therefore, your sum of 51 terms is equal to, then you punch this in your calculator. But your last L should be the last term, which means should be the term, should be this term in which you're finding the sum for. So 51 over 2 times 5 plus 105. So the sum of 51 terms is The sum of 51 terms is 2,805. So here is the sum of 51 terms. So this is the 5. So after this we go to 4.3. But I'll first clean the board and then we go to 5.3. Okay, so now we are doing 4.3. Write down the expansion of this sum. Right? Show only the first 3 terms and the last term of the expansion. So, let me read this again. Write down the expansion of this series here. Only show the first 3 terms and the last term of the expansion. So they want us to write to expand the expansion of this, but only show first 3 terms and the last term of the expansion. So how do you do this? So here is your nth term. So your Tn here is equal to 2n plus 3, right? So you're told that this series starts at n is equal to 1. So the first term here will be at n is equal to 1, right? So T1 is equal to, you say 2n plus 3. The answer is 5. You put your 5 there. Plus. Go to the second term. N is equal to 2. T2 equal to 2 times 2 plus 3. This is 4. This is 7. So you have 7 here. Plus. N is equal to 3. Which is equal to T3 is equal to 2 times 3 plus 3. This is 6 plus 3. This is 9 plus 9. Right? This is the first 3 terms of the sequence, of the series, which they wanted to show. And then this series continues, right? And now we must find the last term. It starts at 1 and ends at 5,000. So the last term will be at n is equal to 5,000. So T 5,000 is equal to what? It's going to be 2 times 5,000 plus 3. 2 times 5,000 is 10,000, right? Plus 3, so it's 10,000 and 3. So this is term number 5,000. So this is the last term. So you have 10,000 and 3. So this is what they want us to show. They say they want to see the first 3 terms and the last term of the series. So this is what we have. We're done with this question. Go to the next one, 4.4. So now we're doing 4.4. Hence or otherwise, calculate the value of this thing here. They wanted to find the value of this thing. And then they went on to say, all working details must be shown. All working details must be shown. So they want us to find the value of this thing. What do we do here? What I'll do first, I'll say, okay, I have this summation here. So it's 5,000. It's from 1 to 5,000. Off to n plus 3, right? Plus this summation here from n is equal to 1 to 4,999 of negative 2n plus 1. Took that negative as a common factor there, right? Actually, no, I will not do it this way. I'll just clean this part here, this part here. I'll write it as it is. I'll say, okay, I have 4,999 and it's equal to 1 negative 2n minus 1, right? And then here I have 5,000 terms. Here I have 4,999 terms. Then what do I do? I'll say, okay, the last term here is 1,000. The last term here is 10,003. So I'll say, okay, 10,003 plus. Then, if we exclude this 10,000 to the front here, Here we're left with 4,999 terms. N is equal to 1 of 2n plus 3 plus 4,999. N is equal to 1 minus 2n minus 1. So here, well, we had 5,000 terms. But now, if we exclude the last term, which is 1,000 out, in here we're left with 4,999 terms, which is the same number of terms as this one here, right? So the term number 5,000 is that one over there. So it's not lost, because if we add it back, it goes back to this. But if we take it out or write it separately, it becomes that, and then we're left with this. Then now, what do? We say, okay, if we look here, we can see that we can take this thing as a common factor here. And then we have 10,003 plus 4,999, which is starting at 1. Then what do we have? We have 2n plus 3 plus negative 2n minus 1, right? So now we've taken the common factor, and then now we're adding these two. Then you'll find that you have 10,003 plus this from n is equal to 1 to 4,999. Then add this, and that goes away. Then what are you left with? You're left with 3 minus 1, which is 2. So we have 10,003 plus a series from 1 to 4,999. So what is this? So now what you're adding, what this tells you, this part here, you have the terms that are here. The terms that are here, they are 4,999, right? But what terms are those? All those terms are 2's. So we have 4,999 worth of 2's. Or you are adding up 4,999 2's. That's what we are doing. So what you are left with, essentially, is 10,003 plus 4,999 of 2's. And then what is your answer to that? Just add this on a calculator. So what? 10,003 plus 4,999 worth of 2's. So I'm left with 20,001. So this is the sum of this series. And we're done here. Move to the next question. Thank you for